Okay, so for this first question, it says a car is traveling north towards an intersection at a rate of 60 kilometers per hour. So what we want to do is we have an intersection. So we'll mark down our intersection, and we have a car traveling towards that intersection going at a rate of 60 kilometers per hour. So the car is traveling north towards the intersection, which means that where the car would be situated is south of the intersection, and the car is traveling towards the intersection, and the rate at which the car is traveling is 60 kilometers per hour. So what I'm going to do is I'm going to say, okay, I'm going to pick a variable to relate the distance from the car to the intersection, and I'll pick the variable x. And then the rate at which the car is traveling is 60 kilometers per hour. So I will say that the rate at which the distance is changing, the rate at which x is changing with respect to time is 60 kilometers per hour. Now, what happens is the intersection is technically the origin, and you're either going to have cars moving towards the intersection or away from the intersection. What's going to happen is because the car is getting closer to the intersection, this x is going to be becoming a smaller number, so the rate is actually going to be negative. So when you go towards the origin, it's a negative value. When you go away from the intersection, it's a positive value. So we're going to actually mark this as negative 60 kilometers per hour. Then what it says is it says there's a truck traveling east away from the intersection. So from the intersection, we have a truck that's traveling east. So that's the distance that the truck would be traveling. I'm going to denote this length to be y. And it says that the rate at which the truck is traveling is 50 kilometers per hour. So dy dt is equal to 50 kilometers per hour. What happens is we could turn this into a right angle triangle, and the right angle would be right here. Okay. What it's asking for is find the rate of change of the distance between the car and the truck. So the distance between the car and the truck would be z, and it wants how is this distance changing. So that would be dz dt. So it's asking how is the rate changing between the car and the truck. And then it's going to say, it's going to give us, it says find the rate of change of the distance between the car and the truck when the car is 3 kilometers south. So the car's here, so that would be x. So they want the rate that this distance is changing when x is equal to 3. So this guy would be x is equal to 3. So what I'm going to do is I'm going to go back to my rate down here, and I'm going to say they want the distance when x is equal to 3. And the truck is 4 kilometers east. So the truck 4 kilometers east, that would be, this is the truck, which would be y. So when y is 4. Okay. So the first thing is you're going to say, okay, what type of problem would this be? Well, this is a right angle triangle, so this is Pythagorean's theorem. Remember, we need to come up with a formula that would relate x, y, and z. And what would that formula be? So what's a formula that's going to relate x, y, and z all together? Yeah, or x squared plus y squared is z squared. So this is going to be a Pythagorean's theorem question. So x squared plus y squared is equal to z squared. Okay, so that is the formula that's going to relate all of my variables. And we're going to be trying to figure out what dz dt is. And I know if I differentiate both sides of this equation with respect to time, I'm going to have dz dt, right? So what I'm going to do is we're going to implicitly derive both sides with respect to time. So the derivative of x squared is 2x. I just took the derivative of x, so dx dt. The derivative of y squared is 2y dy dt. The derivative of z squared is 2z dz over dt. What I'm going to do is if I've got 2 on, like each term has 2, I could actually just cancel out those 2's. I'm trying to find dz dt. Okay, so this is what I'm trying to find. And I'm going to say, do I have all these other pieces of information? I know what dx dt is. It's negative 60. I know what dy dt is. It's 50. I know what x and y is. Do you know what the one piece of information I'm missing is that I'm going to need to solve before I plug everything in? Z. So what we could do is we could create another little triangle here. So it wants to know, it said when x was 3, when the car was 3 kilometers and the truck was 4 kilometers. So draw yourself another little triangle here. So here's the car at 3 kilometers. The truck is at 4 kilometers. Let's figure out what z is. So z squared equals x squared plus y squared. Z squared equals 3 squared plus 4 squared. Z squared equals 9 plus 16. Z squared is equal to 25. And this is distance. So z is not going to be plus or minus 5. It's going to be 5. So now I actually have got everything. Okay, so x was 3. So that was when the car was 3. Dx dt was negative 60. Plus y was 4. Dy dt was 50. Is equal to z we just calculated to be 5. And dz dt is what we're looking for. So 3 times negative 60 is negative 180 plus 200 is equal to 5 dz dt. Negative 180 plus 200 is 20 is equal to 5 dz over dt. Divide both sides by 5. And we are going to get dz over dt is equal to 4. Now, what would the units be? What would it be? Kilometers per hour. Okay, so this would be kilometers per hour. Now let's see if we could sort of figure out, like, what was it we just solved? So the car is moving towards the intersection at a rate of 60 kilometers per hour. The truck is moving away at a rate of 50 kilometers per hour. The distance between the car and the truck, how that's changing, so the rate of change of the distance between the car and the truck, it's changing. They're changing at a rate of 4 kilometers every hour. So every hour they're getting 4 kilometers more apart from each other. Okay, is how the rate of change between the two vehicles is changing. Let's do another very similar question, but there's going to be one new piece that we have to try to figure out how we're going to deal with. So a man starts walking north at a speed of 1.5 meters per second. Okay, so what we have is the man and the woman actually are going to start at the same point. So we're going to have a point P. So let's do point P. And it says a man starts walking north at a speed of 1.5 meters per second. So let's draw him going north. We have to pick a variable to represent the distance that he walks. So let's pick the variable x for the man. And he's walking at a speed of 1.5 meters per second. So I'm going to say dx over dt. The rate at which he's walking away from the origin is 1.5 meters per second. At the same time, a woman starts at the same point P At the same time, she walks west. So now draw an arrow going west. So she's walking in this direction. Let's call her distance y. And it says that she's going faster. She's walking at a speed of 2 meters per second. So dy dt is going to be 2 meters per second. The distance between the man and the woman would be this, and that would be z. And that distance is going to be changing. As they keep walking further and further away from point P, the rate at which z it's going to change with respect to time. So dz over dt. Yes. Yes. Doesn't matter. So you kind of look for your reference of like what would the origin be? That's your reference point. And going towards the origin is always negative, going away is positive. Yeah. So for example, if I said that, let's say she was walking away and he was walking towards, if he's going in this direction, he would have a negative rate. Okay. So then it says, at what rate is the distance between the man and the woman increasing 1 minute later? So they want to know dz dt, and what they want to know is that rate when, and they're not giving me like a distance this time, they're actually giving me a time. So when time is equal to 1 minute. Now, looking at this question, what units should time be in? Seconds. So I'm going to change that to 60 seconds. Okay, so here's how we're going to figure this out. I want you to draw that little triangle. So here was point P. And we can actually figure out in 60 seconds how far he got. He goes 2 meters per second, right? So if I want to know at 1 minute, at 60 seconds, what is y? So y is equal to, he's going 2 meters per second, and I want to know how far does he go at 60 seconds. How far is he after 1 minute? How far did he walk? 120 meters. So he walked 120 meters at 1 minute. Okay, to figure out her distance at 1 minute, so she's going 1.5 meters per second. So 1.5 meters per second. After 1 minute, that's 60 seconds. Do you guys know what that distance would be? 90. Yes, that would be 90 meters. The other way you could have figured this one out, do you guys know what 1.5 would be as a fraction? It's 3 over 2. So 3 over 2 times 60. And then I'd say 2 goes into 2 once, and 2 goes into 60 30 times, and 3 times 30 is 90. So this is 90. Now, watch the Pythagorean's theorem for this. The Pythagorean's theorem for this guy is going to be a little bit crazy, but you have to know how to do this for the test. So z squared equals x squared plus y squared. Z squared equals, actually, you know what might even be easier? Um, it is going to be, you know what I was thinking? We could actually, like, instead of doing 90 squared plus 120 squared, we could do 9 squared plus 12 squared. So, do you know what I'm sort of saying? Let's actually change this. Instead of 90, let's remove a 0, and let's do 9 squared plus 12 squared. And let's see if our numbers are a bit nicer. Z squared is equal to 81 plus, what's 12 squared? 144. So you have to know 12 squared. Okay, does anybody have what 81 and 144 is? It's 225. And then does anybody know the square root of 225? It's 15. Yes, now I'm going to add a zero back. So Z is actually 150 meters. Okay, so going back to my original diagram, this would be a Pythagorean's theorem question. So how I'm going to relate these three variables is I'm going to use Pythagorean's theorem. So I'm going to say x squared plus y squared equals z squared. I'm going to differentiate both sides of my equation implicitly with respect to time. And I'm going to get 2x dx dt plus 2y dy dt equals 2z dz dt. Eliminate your 2's because that will leave, your numbers will be much smaller that you're dealing with. X is 90. Dx dt is 1.5. Plus y was 120, so there's y. Dy dt is 2 equals z is 150, and we're trying to find dz dt. 90 times 1.5. Alex, what are you getting? You said 45, which is like half of, yep. $135. Yep. Plus 240 equals 150 dz dt. 135 and 240 is 375. Okay. Dz dt is 375 over 150. And then what would you guys first? Oh, okay, that's even, I was going to say 5. But yeah, you want to say like, what are you going to break these down by? So Carly saw right away that it was 25. Both of these numbers are divisible by 25. If you didn't see that, you'd be breaking it down by like, what's 375 divided by 5? What's 150 divided by 5? And then you're going to further reduce it. How many times does 25 go into 375? Oh, okay. So sorry, what did you get then? Yes, actually it is, but so it's going to reduce even more. Over 6. So that actually means there was a bigger number. Okay, what does 15 over 6 reduce to? That reduces to 5 over 2, which means that the number wasn't 25. What was each of those numbers divisible by? 75. Yeah, so 75 goes into this guy twice. 75 went into that guy 5 times. But like I wouldn't have even seen that. And then this is a rate. Oh, and what would my units be? Yep. So dz dt is going to be 5 over 2 meters per second. So the rate at which the distance between the man and the woman is changing is 5 over 2 is 2.5 meters every second. Or the distance between the man and the woman as they walk away, they're walking away at a rate of 5 meters every 2 seconds. That's how the rate is changing. Okay? Those are your Pythagorean's theorem questions. You'll have at least 2 to practice. Oh no, let's do one more Pythagorean theorem. the famous ladder question. A 6-meter ladder is leaning against a wall. So this ladder is 6 meters. And what letter do you think I'm going to let the ladder be? Z. Okay, what's happening is leaning against the wall. Its foot is sliding away from the wall. So this is what's happening. The foot is sliding away from the wall. The foot's going in that direction, which means that the top of the ladder, do everybody agree, would be going down? Okay. So what we want to do is we want to denote one side to be x and one side to be y. So I'm just going to call the base x and this y. Now, the origin is technically right here. So what it says is um, the foot is sliding away from the wall at a speed of 1 meter per second. So the rate at which this distance is changing is 1 meter per second. So dx dt is equal to 1 meter per second. And then it says, find that rate at which the top of the ladder is falling. So what they're going to ask for is what is dy dt. Okay, so we're finding this. Now, according to this picture, will this rate be a positive or negative number? What should it be? If this is going down, it'll be negative. So I'm just going to put negative here to kind of remind me that hopefully we get a negative answer. So it says, find the rate at which the top of the ladder is falling when, it's going to give me a distance, when the foot of the ladder, so it says when the foot of the ladder is 3 meters from the wall. So what letter is going to be equal to 3 for this? Yes. So when x is equal to 3. Now, if I draw my little snapshot down here, I know that this is 3. They want to know the rate when that guy is 3. My ladder is 6. Can I use Pythagorean's theorem to figure out like what the height of the wall is? Yeah. So this guy was y, so let's figure out what that would be. So x squared plus y squared equals z squared. 3 squared plus z y squared is equal to 6 squared. 9 plus y squared equals 36. Subtract 9 from both sides, and we're going to get y squared is equal to 36, 27. Y is equal to the square root of 27, and then reduce this. So reduce the square root of 27. 27 divided by 3 is 9. 3 and 3. So Emily, what's the square root of 27? 3 root 3. So when x is equal to 3, y is equal to 3 root 3, and the ladder, z, is equal to 6. Okay, so we are going to relate x, y, and z using a formula, and that formula is going to be Pythagorean's theorem. X squared plus y squared equals z squared. Now, before we implicitly derive, I want you to star something. So from yesterday, I told you that if anything is fixed, you plug it in before you implicitly derive. So remember that yesterday when we were filling up the volume of like the cylinder, the radius doesn't change. That would be fixed. Do you know what's never going to change in this diagram? The ladder. Yes. So anything that's fixed gets input before you implicitly derive. So ladder is fixed. So that means that the equation, and it'll be so much easier if there's something fixed, because watch what will happen. X squared plus y squared is equal to, the latter was 6 squared. So this would be x squared plus y squared equals 36. And now, when we implicitly derive both sides with respect to time, what's the derivative of 36? What's the derivative of a constant? 0. Okay, so the derivative of x squared is 2x dx dt, plus the derivative of y squared is 2y dy dt, equals derivative of 36 is 0. So from here, I guess we could have actually divided out those 2's. But I'll just show you if you didn't, what you would get. You get the same answer. So 2 times x is 3, and dx dt is 1, plus 2y we got is 3 root 3. dy dt is what we're solving for. You guys, this is how you would know, like, let's say you forgot to input that. What you would have had over here is you would have had 2z dz dt if you forgot about this, like, over here. What you're solving for is this guy, and you wouldn't have dz dt to put in. So you'd be like, why don't I, like, why is that missing, right? And that's how we get rid of it, because the ladder was fixed, is equal to 0. Okay, so now I've got 6 plus 6 root 3 dy over dt. Might have been easier if I would have just divided out that 2, but we'll get the same thing. Is equal to 0. Bring that 6 over to the left, and then divide by that 6 root 3. So negative 6 divided by that 6 root 3. So the rate at which the ladder is falling, this is the rate at which the ladder is falling. This will go into each other once. So this is the answer. Though remember that some professors might want it rationalized, so just be careful. If they want it rationalized, then that would be negative root 3 over 3. And so the ladder's falling at a rate of whatever this decimal would be, and then the units would be meters per second, is the rate at which the ladder's falling. So intersection questions, ladder questions. Then there's going to be shadow questions. Now, for shadow questions, there's 2 types. It's either a spotlight or a lamp post. We're going to do each. Your exam would have one of the 2 types. Okay, so I'll show you the spotlight, and then I'll show you the shadow. A spotlight on the ground shines on a wall 10 meters away. So the distance between the spotlight and this wall here is 10 meters. So this distance is 10 meters. A man is 2 meters tall. So draw a line here. That man is 2 meters tall. And he's walking away from the spotlight towards the wall. So he's walking in this direction. The spotlight is technically the origin. So the spotlight is the origin. He's walking away at a speed of 1.2 meters per second. Okay, so I don't know how far the man is from the spotlight. So I'm going to pick, because they put y here, I'm going to pick the variable x to be the distance from the man to the spotlight. Now, that distance is changing at a rate of 1.2 meters per second. So he's walking away at that rate. So dx over dt is equal to 1.2 meters per second. What happens is if you have a spotlight behind you on the ground, you're casting a shadow on the wall. So this distance here is the shadow. So y is actually the shadow. And what I'm going to recommend for these questions, just so that your work will sort of match like my answer key, I always let the shadow be y. So let shadow, like it really doesn't matter, but my work, I just said, okay, I'm always going to make the shadow y. Let shadow equal y. Okay, so I want you guys to think about this for a second. As he gets closer to the wall, where he is right now, this would be his shadow projected on the wall. As he gets closer to the wall, is his shadow getting bigger or smaller as he gets closer to the wall? Yes. So as this little 2-meter man guy gets closer to the wall, this shadow is going down. Okay, so this will be the rate that y is changing should be a negative value. So how fast is the shadow on the wall decreasing? It actually tells us. So dy over dt is equal to. So they want us to figure out that rate. It's negative when the person is 3 meters away from the wall. Okay, so we got to think about this. Do you guys know what x would be? Yes, x is 7. When he's 3 meters away from the wall, so like let's say that's right here, if that was 3 meters, the distance is 10, x would have to be 7. So when x is equal to 7. Okay, these shadow questions are similar triangle questions. So what happens is I actually have two triangles within this diagram. I've got this little tiny triangle right here. So let's draw that little triangle off to the side. That little triangle would be, this would be x, and that would be 2. And here's my angle of this triangle. The second triangle that has the exact same angle would be the big triangle. So it has the exact same angle. And I know that from here to here, what would this base be for this triangle? It'd be 10. The distance from the spotlight to the wall is 10. And I know that this is y. So what we could do for similar triangles, it's proportional reasoning. So for example, if I said, like for this triangle here, opposite over adjacent, so if I said 2 over x, so if I write 2 over x, that is going to be equal to, because they've got the same angle, what would it be equal to in this triangle? Y over 10. Okay, so for these questions, you're going to get two triangles, and you're going to proportionally relate the two sides together. Then what we're going to do is we're going to cross multiply. So let's do 2 times 10 is 20 is equal to x times y. And then from here, you're going to implicitly derive. Okay, so we're going to take the derivative of both sides with respect to time. Now, the derivative of 20 is 0. And how am I going to take the derivative of xy? What am I going to do? uv prime. So this is u, and that's v. So u is x. V prime, the derivative of y is 1, and then it's dy dt. So uv prime plus v is y, and u prime is derivative of x is 1, and then it's going to be dx dt. Now, fill in everything, and it's going to look like one thing is missing. but I'll show you what we do. So 0 is equal to, I know what x is. Sarah, what do they want x to be? X is 7. Oops, x is 7. Okay, dy dt, that's what I'm looking for, right? This is what I'm looking for. So that's good that I don't know what that is. Plus y, so I'm just going to put that down for a second. Dx dt, I know what dx dt is. Dx dt is 1.2. Okay, so the first couple times you do these shadow questions, you're going to say to yourself, I'm doing something wrong because I can't have two unknowns. You could actually figure out what y is based on this equation here. So you had 20 is equal to x times y. Shayla, what would y be equal to? Yep, y is equal to 20 over x. And do we know what x is? Yes. So y is actually 20 over 7. Because you'd say to yourself, was there something fixed that I was missing or what it was? But no, it's just that y is 20 over 7. So now I've got 0 is equal to 7 dy dt plus y is 20 over 7 times 1.2. Okay. Let's subtract this. So let's bring that guy over. So negative 20 over 7 times 1.2 is equal to 7 dy dt. From here, I'm going to get rid of this 7. Instead of dividing both sides by 7, I'm just going to multiply this by 1/7. And I'm going to multiply this by 1/7, just so you could sort of see it a bit better. This is the same thing as dividing by 7, right? My 7. So I want to get rid of this 7 by dividing both sides by 7 or multiplying both sides by 1/7. So now I've got dy dt. So the rate at which the shadow is decreasing, it's decreasing at a rate of negative 20 times 1.2 over 49. Okay. Can't cancel the 7s because it's 7 times 7. Because do you guys know what 20 times 1.2 would be? It'd be yes. So if this was a 6-mark question, if you got up to here, you'd get 5 out of 6, or you get 5.5 out of 6 for this. 20 times 1.2 is, she said, 24. So the answer for the last 0.5 would be negative 24 over 49 meters per second. So the shadow is decreasing at a rate of, it's going down 24 meters every 49 seconds is what's happening. Okay. And again, you'll practice each one of these in your homework. Okay, here's the street light question. So it's either a spotlight or a street light. A 6-foot man walks away from a street light 21 feet high. So here's what we have happening. Carly, I'll look at yours after to find. How did you, Abby, how was it you did it? 1 point, like how did you rationalize that one? Like, you know how you said it was 24? She's asking how you, or you just knew? She just multiplied it like longhand is what she's saying. So she would have, um, yeah, so she would have done 20 times 1.2. And she would have multiplied like 2 times 0 and 2 times 2. So 2 times 0 is 0, 2 times 2 is 4, and then you add a 0 here. 1 times 0 is 0, 1 times 2 is 2. and then 24.0. That's how you did it? Yeah. Okay, draw yourself a street light. Draw yourself, oh, and a street light is 21 feet high. So this distance is 21 feet. Draw yourself a little man. And he is 6 feet. Okay, he's walking. A 6 foot tall man walks away from the street light. So he's going like in this direction at a rate of 3 feet per second. So what happens? So he's walking away from the street light. The street light is going to shine down. Do you know where the shadow would be for this question? It's on the ground. Do you know if the street light is behind you? Is the street light will always be orientated in the same way. Where's the shadow? Is the shadow, like, does it fall on the ground in front or behind when the street light is behind you? Yes. So this from here to here would be, oh, I said I put Y for, but in my, for whatever reason, I actually put S here. So that's actually his shadow. Okay. I don't know the distance from the street light to the man. I don't know what this is. So I'm going to call this X. Okay, so let's see what else we could write. Origin is technically right here. Yeah, he's walking away from the light. When you walk away from the street light or the spotlight, positive. Okay, so it says that the man is walking away at a distance of 3 feet per second. So the rate at which he's walking, dx dt, is 3 feet per second. At what rate is the shadow of the jogger changing? So that would be ds dt, because if you think about it, as he goes further and further out, that shadow is going to be moving as well. So at what rate is the shadow changing? When he is 8 feet from the street light. So that would be when x is equal to 8. There's two triangles that I need you to see from here. And your angle would be right here. That would theoretically be your angle. So the first triangle is the one with the street light. It's the big one. And the first triangle, it would be 21. And then do you guys know what we would say for like this distance down here? If this is x and this is s, it'd be x plus s. Yeah, it'd be x plus s. The second triangle is created with the man. The man is 6 feet, and there's his shadow. These angles are the same, so they're similar triangles. So I'm going to relate 21 over x plus s to equal 6 over s. So 21 over x plus s is equal to 6 over s. Now, remember we're going to be implicitly deriving. I don't want to do quotient law. So for these similar triangle questions, always cross multiply. So cross multiply, and you're going to get 21s is equal to 6 times x plus s. 21s is equal to 6x plus 6s, or I could have had that as by because that's my shadow. Join your s's together. So let's subtract 6s and subtract, and we get 15s is equal to 6x's. And then we're going to implicitly derive both sides with respect to time. Okay, the derivative of 15s is 15 ds dt, and that's equal to derivative of 6x is 6 dx dt. I'm solving for ds dt, and I know dx dt is 3. So 15 ds over dt is equal to 6 times 3. ds dt, so the rate at which the shadow is changing with respect to time, it's 18 over 15. Akil, what would that reduce to? 6 over 5. And that was feet per second. 6 over 5, you don't need to know what that is as a decimal. It's 1.2. So the shadow is increasing at a rate of 1.2 feet every second, or 6 feet every 5 seconds. Okay? There is the lesson. So I want you to do these 3 first. A spotlight, a ladder, 2 cars moving away from the same point starting at noon. So I want you to start with these 3, and then I'll find which ones from here.